In this video, we're going to look at different functions along with how to graph their transformations. First thing I want to look at are the parent functions, or some very common types of functions that we'll see. So for instance, the first one we see here is the x squared function. On the left, we have the function itself, f of x equals x squared. And on the right, we see what the graph looks like. I've shown you 5 points in particular. We see the point 0, 0, 1, 1, negative 1, 1, and 2, 2, 2, 4, and negative 2, 4. Now, how could we get that? The easiest way to figure those out is just create a little xy table. And just by plugging in those values, negative 2, negative 1, 0, 1, 2. If we take negative 2 and square it, that's what the function tells us to do. We get the 4, negative 1 squared 1, 0 squared 0, and so forth till we get the 1 and the 4 to complete our table. Once we have those values, we can put those on the graph fairly easily. We see the 0, 0, the 1, 1, negative 1, 1, 2, 4, negative 2, 4. We're going to do the same throughout for all these functions. The reason I've chosen some negative values, some positive values, is because obviously the x squared function changes how it behaves on the positive and negative side of the y-axis. So we're going to do the same for all 5 functions that I have listed here. If we take x cubed, the next function, negative 2 cubed would be a negative 8 because we keep the signs the same. Negative 1 cubed is a negative 1, 0 cubed 0, 1 cubed 1, 2 cubed is 8. So we notice we have the 0 and the 1s stay the same. We still have that point 0, 0, 1, 1. But the next points, or the other points, change. At 2, we're going to have 8, so that would be way up here somewhere. And negative 2, we would have negative 8, which would be way down here somewhere. And then negative 1, we see, of course, the negative 1 that's been plotted. Now, on the labs or any homework that I collect, I want to see at least 3 points. So on the first one, I did 5 points. That was just to kind of illustrate how the graph behaves. This one, the x cubed function, I only showed you those 3 points, but we do need to know how it behaves around those points. We wouldn't just, for instance, want to draw a straight line between the 3 because that's not how the function looks. So we do want to think about the entire negative 2 to 2 table when we're drawing out these functions, but we only need to draw those 3 inner points. If we take the square root of x, here I'm going to have a little bit smaller of a table because we can't do the square root of negative values. So I'm going to just start at 0 and go to 1 next, and then the next x value I'm going to use, rather than using 2, I'm going to use 4 because the square root of 2 is not a nice number. It's not a nice whole value. If I take the square root of 0, that's 0, square root of 1 is 1, square root of 4 is 2, and we see those 3 points, 0, 0, 1, 1, and 4, 2 on our graph. Moving right along, we'll move down to the fourth function, the cubed root of x here. Same idea, we'll set up a little xy table, but once again, I want to consider negative and positive values because I could have negatives. I can do the cubed root of negative values. So maybe I'll pick negative 8 because that's going to work out to be a nice whole number. Negative 1, 0, 1, and 8. Cubed root of negative 8. Negative 2 multiplied by itself 3 times will give me a negative 8. Negative 1 cubed is, or cubed root of negative 1 rather, is negative 1. Cubed root of 0 is 0. Cubed root of 1 is 1, and then cubed root of 8 is 2. So once again, I've only graphed those 3 inner points because the negative 2 would be, when we get y to be negative 2, would be very far over here to the left, would be off my graph paper, and then the 8, 2, that would be way over here to the right, again, once again off my graph paper. This is another one of those, we don't want to just try and connect those 3 dots. We're going to get another linear function, which of course is not what this looks like. It is the sort of wiggle function. Looks very similar to the x cubed up here. It's just been slightly rotated. And then finally, our last graph, we see the absolute value function. And we can set up a similar xy table. Negative 2 gives us 2, negative 1 would give us 1, 0, 0, 1, 1, and 2, 2. Those are my 5 points. I've graphed them, and I get the sharp v. So we want to remember what these parent functions look like. That's going to be very important. Our first function up here, the x squared, is sort of that u shape, the x cubed. So that wiggle that goes up and down. The square root of x is just starting at 0 and progresses off to the right at a slower and slower rate. The cubed root of x is the same wiggle, but rather than going up and down as the x cubed did, it goes from left to right. And finally, the absolute value of x is the sharper v shape. So we want to know what all these functions look like. Also keep in mind, they all have the point 0, 0 in them, and they all have the point 1, 1 in them. So those are two easy points to remember, and from there, we need to remember how the other points set up around them. Now let's get to the bottom of the page down here. Once we have those parent functions memorized, once we know what they really look like, we're going to be able to shift them just based on what values I'm either adding, subtracting, multiplying, or dividing to them. So if we look at the first bullet point here, horizontal shifts. Anytime we notice that the x value has been changed by either adding or subtracting something inside that parent function, so again the parent function x squared, x cubed, square root of x, cubed root of x, and absolute value of x, anytime we've added or subtracted something directly to that x, it's going to cause left and right movement, a shift to the left, a shift to the right. If we notice that the plus or minus is on the outside, then it's going to be going up, either up or down. So we could look at a couple examples of this. So for instance, x plus 3 inside parentheses squared, that would be horizontal movement. X plus 3 with the x being squared and the plus 3 occurring afterwards, that would be vertical movement. We would see the parent function here, adding 3 to that, vertical shift. Here, this whole thing's the parent function, so it's going to be a horizontal shift. Easiest way to remember how to move the horizontal shifts, any horizontal motion actually, it's always backwards. Anytime you see a plus, it's going to be going to the left. Anytime we see a minus, that's going to go to the right, kind of the opposite of what you would think. Vertical shifts behave exactly like we would expect. So for instance, this plus 3 is going to move it up. The last thing to note down here at the bottom of the page, anytime you see multiple shifts or any multiple transformations, we're going to add other types of transformations very shortly. Horizontal shifts must occur first. Vertical shifts must be the very last thing we apply. So let's look at a very basic function. Let's take that x plus 3 squared. If we think back to a second ago, we saw that the x squared function had the point 0, 0, 1, 1, negative 1, 1. I'm going to go ahead and move those. What I'm going to do, I'll plot that basic function first. And this is obviously a little bit off. That looks a little bit better now. So that would be our x squared function. What I'm going to do is I'm going to take that function and I'm going to shift it left 3. So at this point, I'm going to move over 1, 2, 3, right there. This point, 1, 2, 3. And then this point, 1, 2, 3. And we now see the exact same function, just been shifted over to the left by 3. That's one way we can think about it. If we apply a lot of transformations, though, we can kind of lose what we're doing in there. So one thing that you can do, or another thing you can do, is you can set yourself up a little table. So if we set up the basic x squared points, we would have the point, like I said, 0, 0 is always a nice easy one to base off of because that's always a point they all have in common. Then our 1, 1, negative 1, 1, and then of course remembering that x squared is a u, we wouldn't want to draw it as a sharp v. We're going to take these and we're going to move each point left by 3, which means we're really taking x and subtracting 3 because remember, we're always doing the opposite of whatever the parent function told us, or whatever the original function told us to do, not the parent function. So we'll have negative 3, 0, negative 2, 1, and then negative 4, 1. And notice when we graph those are the exact 4 points we graphed on our blue figure. I don't mind which method you choose to graph these things, whether you set them up in the table, whether you move each point as I did in the first example, but always make sure it's clear to me what your final function is. So in this case, I've drawn it in blue. I'll label it final. You could make separate graphs, kind of sketching each step along the way, and then label that final graph your final picture, but it needs to be clear what that final picture looks like. All right, let's look at another function. This time I have f of x is equal to the square root of x minus 1 all under the root, and then the plus 2. So we're going to have two different transformations. Remember, horizontal shifts always come first. So we're going to look inside that parent function, under that square root, because the square root's our parent function. Under that square root, we see a minus 1. That means the first thing we're going to have to do is shift to the right 1. Then we're going to have to take care of that plus 2. That's again going to be a shift because it's plus. We're going to shift up 2. So let's think about what the basic square root of x function looks like. 0, 0, 1, 1, and then 4, 2, and it's just a single bend out from there. I'm going to take care of that shift to the right first. So every single point, I'm going to move it to the right. This would be my first transformation. And then I'm going to shift that thing up by 2 units, so that point's going to jump up here. Next point is going to jump up here. And finally, we're going to be up here. And so the red function here is my final function. I'll label it f of x. We could have set up the table in the exact same way. So if we think about the square root of x function, what it initially looks like, 0, 0, 1, 1, and then 4, 2. We would first take care of that shift to the right. So I'm adding 1 to all the x's. So I'd have 1, 0, 2, 1, and 5, 2. And then we would go ahead and shift that thing up 2. And so we'd have 1, 2, 1, 2. Say what I write. 2, 3, and 5, 5. 5, if I could add, that should be a 5, 4. And notice those are the exact points we got in that final red function. So it doesn't matter whether we choose to move the points in a table or whether we choose to do it on graph paper. Either way, we're going to get to the same place. It sometimes is a little bit easier to follow the work, your own work inside a table, because it could be a lot of different transformations going on. You could lose where